This is Mr. TG. This is the second lesson on factoring and section 4.4 Algebra 2A. The first type of factoring I'm going to demonstrate for you is called factoring out the GCF. GCF simply means greatest common factor. It can be used periodically with these polynomials, and I'll show you two examples where we can actually factor out a GCF. Looking at number 1, or number 5, I should say, you compare the first term to the second term. First, we look at 3 and 24 and ask a simple question: what's the highest number that goes into 3 and 24? And that highest number would be, of course, 3. They share a 1, of course, and they also share a 3. We want the highest. So you put a 3 down as part of the GCF. Then you look at the variables. You have an x squared and an x. So the first term has 2 x's being multiplied. The second term has just 1. How many x's do they share? And they, of course, share just 1 x. So you end up with 3x. That's called our GCF. So if you're going to use factoring out the GCF, you've got to find that GCF. If there isn't any GCF within your polynomial, then you just can't use this technique. The next step with factoring out the GCF is put a parenthesis next to your 3x that you found. Then simply, again, thinking backwards, ask yourself, 3x times what is 3x squared? 3x times what is 3x squared? Well, I think x would work nice there, because if we take 3x times x is 3x squared. Plus, then what we have to do here is we have to figure out what would be placed here to get 24x. So we would need an 8. And we already have an x. So if we took 3x times 8, that would give us 24x. There is an example, and it's completely factored, of factoring out a GCF. It also works when we have trinomials, 3 terms. If you take a look at over here, we have 3 terms. Now remember, for it to be the GCF, it must be shared by all 3 terms. So if I look at 10, -4, and 2, I notice that 2 is a common factor. It's the greatest common factor of 10, 4, and 2. That simply is the highest number that goes into all 3 of those coefficients. They also share an x. You got an x cubed, there's 3 x's here, there's 2 x's here, there's 1 x there. So you'd simply factor out an x also. So again, if we're going to use the GCF factoring technique, we are going to need to find a GCF, which was 2, because 2 is the highest number that goes in the 10, -4, and 2. And x goes in all 3 terms because they all have at least 1 x in common. Then you figure out what goes first. Well, we need a 5. 5 times 2x is 10x, but we also need 2 x's to make that x to the third. So we go 5x to the second power. If I multiply 2x and 5x squared, I get 10x to the third. Minus, I need a 2 here because -2 and +2 will give me the -4, and I need another x. And then you'll notice the last term is my GCF, so I have to place a 1 there so that I'm capable of multiplying all these back together again to get the original polynomial. Again, we factored out a GCF out of all 3 terms, and we were successful in that process. So that's what factoring a GCF is. Now, factoring the differences squares. First of all, I look at these 2 terms and I check to see if they're perfect squares. I can take the square root of x squared and get x, and I can take the square root of 36 and get 6. And if I'm subtracting, I have what I call the difference of perfect squares. Anytime you have the difference of perfect squares, you can do this. Simply write the factors as x minus 6, x plus 6. And what will happen here is the same thing that happened up here in our notes when we multiplied in number 3. X minus 8 and x plus 8 became x squared minus 64. That was the difference of squares. That's always going to happen. The O and I will cancel out. So that is what we say is completely factored, using the differences squares. Number 8 is also the differences squares. 9 is a perfect square, x squared is a perfect square, 64 is, and we are subtracting. So we break it down like this: 3x minus 8, and then you want to make it 3x plus 8, making sure that the signs are different so that O and I cancel out. So this is an example of what we call the difference of squares and how to factor binomials that are the difference of squares along with the GCF. So this is video number 2. We'll move on now to factoring trinomials.